What's going on, everyone? Welcome back. We're going to continue working on this acrylic sign that I'm working on. Um, I don't really have anything I don't have anything planned out for tonight. I'm just going to keep working on it as I see fit. So, as usual, if you have any ideas, let me know, or anything you want to chat about, let me know. But yeah, let's jump in. Whoops, muted the wrong thing. Hold on, turn on the music. There we go. All right. So, anyways, our current goal, that's probably needs to be updated actually. We created the requirements. We need to design the base. So give me just a second here. I'll get this fixed. How's it going, book? All right, we're gonna say design. That was completely misspelled. Design base for Inachus light up sign. Okay. As usual, bounties are in play as well, so you can make use of those if you feel like it. Yeah, all right. Let's get started. So obviously, last time we did this, we actually got quite a lot done. We created this neat little base, and then obviously we had the stand-in for our sign. I think we probably need to go in and add the screws that are going to hold this in, just to make sure they're going to fit, and then we need to hollow this base out and start putting the stuff inside to hold the neopixels and everything, and figure out like what kind of pixels we want and all that stuff. So yeah, should be fairly straightforward, but I'm sure it'll have a lot of fun little challenges along the way. All right. So first things first, I need to find the screws. And I picked these screws for, these thread forming screws for plastic. Here we go. And then there's a way to like, I forgot completely how to do this. There's a way to like import stuff. Import, there we go. Probably pull the thing I just downloaded. There we go. So let's turn these off so we can see it. Oops. There it is. I want to get an angle from the other side because I remember this thing. Yeah, here it is. You can see how this, it's not actually round. It's like triangular. I just thought that was odd. How's it going, Pages of Hope? Having a good Thursday? So, just thought that was really weird how it's done that way, but that's to help form those threads. You can see it's sharper on the edges than in this part in the middle. All right. So now we need to get this position in the right place, because obviously it's in the middle there. It's at the origin point. If I move it up, I'm glad you're having a good Thursday. How's it going, Elmac? All right, so if I move that, I could probably look at the sketch for this base and figure out where that screw was supposed to go. That's not it. That's the sketch. All right, over 1.25 and up 0.5. Let me take a screenshot of that. All right, and we can close that. We don't need to modify it. Let's turn that off. Interesting. So you can see the part at different cuts. That's cool. Didn't realize I could do that. All right. All right, so knowing that the placement of this needs to move. So for X, and then I'll have to figure out the thickness of this too. I'm not totally sure on that one. I think I kind of remember the measurements though, so I can do the math on that. I don't know where the origin point of that screw is. It's sticking out over here, so let's see. Well, it's definitely in a weird spot. The center of it is like the origin. So I might just have to move it over half the distance of this. I know this is 1 3/4 inches, so half of that. Okay. So, sorry, on this one. Placement, position. All right, what did we say? We said over 1.25 inches on the X, so that's negative 1.25. And then up on the Y, 0.5. So that should put it lined up with that hole. Yep, there it is. It's just hidden in there. All right, then we need to move it back half of 1.75. .875. I probably should have been able to do that in my head. So I think the z-axis is negative on that. No, it is positive. Wow, okay. Okay. In theory, that puts that in the right spot, and it looks like it does. Looks like it lines up beautifully with the hole there, so. Turn the base off. Yep, looks good. All right, so now I want to turn that off, turn the acrylic on, and make sure that it does indeed fit through the hole without hitting it, which it looks like it does. There's no impact there, and there's a little breathing room too, so. Excellent. And now if we turn both on, all right, we got the screw in there, all lined up. So now we need a second one of these. And what is this thing even called? We probably don't need to do like the whole name. Let's just do _1, and then this one we'll do _2. Okay, and then for this second one, obviously we want to, why is the font so different there? We need to go the other way in the X direction, so X needs to become positive 1.25. And there it is. All right, cool. So we got both of them lined up. Excellent. So now I think we're done with that. We need to hollow out the inside of it. I need to see if there's a way I can round edges in FreeCAD too, because that's going to be these edges are not going to be buildable with like a 3D printer. They need to be a little round at least. So I'm sure there's a method here somewhere. A fillet. Is that what that's called? Unfortunately, I'm not a CAD guy or a mechanical engineer, so I'm learning a lot of this part of it as I go. Definitely much better with the electronics. So in the part design workbench, there's a fillet. So I should be able to, I just want to try this real quick and see if I can get it to work. So select an edge. Let's just say this one. And then active body object, or create one. Oh, there it goes. Okay. So yeah, you can round them. Perfect. So I guess I just got to pick a, pick a radius. So I want to round all of them basically, just because, except for maybe the holes for the screws, just to make it easier to print. All right, let's cancel that. So that's good to know. We know how to do that. All right, now the base. I need to do, I think one of the requirements was cutouts to hang it on the wall, right? Wall mountable was optional. Yeah. So how to do that? That may be the next thing we want to work on here, is making the wall mounts. Probably just draw something and cut it into the side, and then put something on it. I'm just thinking through how to do this. I don't even know what like the standard size of a nail is. Sure, McMaster knows though. Alright, so I'm just looking to see if I can figure... I don't actually plan on buying any of these or using them. I wonder what this... Okay, so size... No drawing. I could probably just create something and be okay. I just want to know some ideal like diameters. Looks like 3/8 is the biggest diameter for something, so that's pretty sizable though. Point 0.2. Okay, I think I have something that'll work here. So I'm just gonna kind of go off this. Um, I'm gonna use 3/8 as like, I'm gonna go for a 1/2 inch as the largest like diameter inside, and then in the slot do like 0.25 inches, because that should be able to handle just about anything. I wish I knew the head size, but I imagine it can't be much. It's not gonna be huge. Maybe 1/8 of an inch is enough to allow for it. Yeah, I think that would be. All right, sorry, I'm just talking numbers to myself. All right, let's turn this off. And these. And we are gonna start a sketch. All right, I'm gonna line them up with these existing holes, so over 0.125. So I need a radius. And then one down here. And then I need same thing for or this other side. All right, then we need to connect them. Okay, hopefully that's everything. If I move them around, yep, they're all connected. Same thing here. Okay. Put vertical constraints and all that. And then I don't want that constraint. Let's get rid of that. Okay, the radius needs to be constrained. And I think we said a 1/2 inch. That's huge. There's no realistic world where somebody needs a nail that big, right? Hold on. That's a 4-inch nail. We're not going to do that anyway. Looks like a 1/4 inch is probably the biggest that we want to realistically plan for. I wish I had something to like look at as reference. Let's see what happens if we go 3/8. That's definitely better. Hmm. Um. Oh, that's radius. That's why that's so obnoxious. Okay, this makes more sense now. It needs to be 0.25 because the because the screw uh, I think this is a diameter is what it's saying. That makes a lot more sense now. Like a lot more sense now. Yeah, head diameter, and I'm doing radius. Okay, that makes more sense. All right, there we go. That definitely makes way, way, way more sense. Um, all right, so these probably don't need to be constrained against each other anymore. Yeah, they'll always be. Well, let's see. Be the next way to do this. Probably between these 2 points. And then these two. So that should hopefully get everything to line up. So now if I move it around, oh no, it can still. Well, that's disappointing. All right, so that one's not necessary to necessarily. Fine, we'll do the distance between the lines. If possible. Nope. Here we go. From here to here. No. I'm trying to think of the way to just do this. There's multiple ways to do this. I'm just trying to think of the cleanest way. That's probably the best way to do it right there. All right, and then we decided if the diameter of this is going to be man, just doing this one feature is going to be really complicated. Okay. Let's see here. The diameter is 1/2 inch. Then the whole thing needs to be 1/2 inch long. And then the distance between the 2 points. Should be definitely half an inch. I guess I get now why those why that constraint exists. This one. What is it called? Tangent constraint. So that should pretty much lock that in place. Okay. We go back to distance again, do the other one. That's invalid. How? So is that. Interesting. I wonder if it's these constraints. No. All right, I'm missing something. It can still move around, so that means, like this one obviously can only slide. That's all it can do. Nothing else can happen here. Yep. So why is this giving me so much trouble? Just delete them all until I figured it out. Please remove the following redundant constraint. Oh, that one's not necessary. Maybe it's freaking out because of that. 9 degrees of freedom. Oh, that works now. I wonder if a sketch is over constrained, if it just refuses to let you do anything. Interesting. All right. That's parallel, that's parallel. And then we got to do tangential. And then this one is 0.5. And then we need to do distance from the center. That's the one that's missing. And I believe that should be -1 or 1.25. Yep, that lines it up with those. And same here. Okay. That's the whole thing. So now we got to decide how far in to cut. Hopefully not very much. Okay, I think that's pretty good. Still leaves a lot open. Alright, so now we need to do the clips kind of thing. Alright. Alright, this is going to be tricky. I'm going to have to build off the previous sketch somehow. And this is probably going to be like a really wrong way of doing this, but... I don't know why that just looks lopsided. Maybe my angle. Okay, let's see. We're gonna do some arcs. So basically I'm gonna try and like make this... Oh no, wait, that's wrong. Escape. Oh no. Go back. Fix that again. Delete this. Oh, I did a circle. That's why it's weird. I need an arc. I needed to go 45 degrees. Is there an arc length constraint? There's gotta be, right? If there is, I don't know how to do it. Oh, fix the angle of a line or the angle between two lines. I don't know if it'll let me do this. I figured there'd be some way I could constrain an arc. Add arc. Hold on, looking something up. Well, I'll figure something out here in a sec. Anyways, we're going to have to do a few of these. That's probably too far. All right, this is going to get really complicated, so I apologize. I'm not even totally sure if this thing's going to understand what I'm trying to do here. So we shall see. All right. So the basic idea is I create something that I can use to then fill back in some of the space that I took out. Maybe it'll work, maybe it won't. Can I copy and like paste all this? I can. All right, I'll do that after I constrain it. All right, let's get started here. Okay, apparently that was too much for it. All right, then radiuses. So we know this needs to be 0.25. This one needs to be smaller. I think we said an eighth, or diameter 0.25, so 0.125 radius. And now I need to figure out how to constrain like how many degrees this is between these 2 points. Here, let's see if I can set a constraint on that. And then one here. Hopefully that's not over. Okay. We're getting there. I don't know if this whole idea of mine of going 45 degrees is going to work necessarily. Oh, it should. If I do this right. 45, 45, 180, those should fill in. Okay. So how to do that? I'm trying. All right, well, let me just go ahead and knock these ones out. Sorry, didn't mean to. That's too much. Here to here. too much. 7.5. There we go. So that should be pretty well locked in. I don't think we can move that. Yep. Okay. Now we got to figure out how to get this all lined up. 1.25. Can this still move? Oh, it can. We want these centers to be the same distance from each other as they were before. All right, how close are we getting? We can still shift that. That's the problem. Everything else is basically locked in. Yep. So if we can figure out how to lock these angles in, we might have something more or less figured out. Let's see. If I do this the same distance from that, maybe that'll get me closer. Okay. So now the only thing that can change is this angle. So I just got to figure that part out. If I constrain these, that might lock that in. Shoot. Okay, I think that works actually. So this would be so this would just be 1 inch from this line here to the center line. And then this would be 0.25 from each other. Okay, let's try that. See if that gives us a... At least I think it'd be 1 inch. No, it'd be 1.125. Yep, that's it. Okay. Oh, no. That would over-constrain something. Can I do distance from each other? That works. So they have to move together now. Do I have to do these radii? Really? That's not everything? Nothing can move. Two degrees of freedom. But where? Oh. Okay, yeah. It's technically a degree of freedom, but it can't physically change anything. Interesting. Okay, well, that's, I guess, easy enough to fix. Honestly, delete that, delete that, delete that. This should just be one arc. If everything else is locked in, that would be probably the easiest way to do this. There we go. From here to here, it's 0.5. And then we do the tangential constraints. And that'll probably lock in the radius. Right? Oh, it can still shuffle around a bit. Fine. If I do a radii constraint, does that fix that? 0.25. Okay, technically it does. I can still move though. Interesting. So I probably need to do it to the center then. Here to here. Hopefully this is acceptable. There we go. Now it's all locked in. Man, that was a lot of work to get that one. All right, let's see if this is going to work then. So I think we went in a 1/4 inch, so this needs to go like an 1/8 inch. Sketch. Can we do negatives? Reversed. Yep, that looks like it works. Okay. Oh man, but it's got these lines on it. That looks horrible. It's basically created these different faces. I really don't like that. The feature works. It looks really good, actually. Okay. How to fix that? It's supposed to be better if we move the sketch in like an 1/8 and then brought it out, had it that way. I don't know if you can do that though. Z is at 1.75 for the sketch. What if I change that? What's minus 0.125? 0.625. 1 point. Oops. Oh, I don't know if I can change that actually. Can you not change the position of a sketch? I guess not. That'd be too easy. All right. It's not honestly that big of a deal. It's just annoying. So I guess I'm going to change this. Delete the square. All right, so then we're just going to add something around the outside here. To make this look a little more normal. Can this one move? No, it can't. It can only extend. There we go. Close. Uh-oh. Error. It didn't like that. Did the opposite of what I needed it to do. Failed to validate broken face. Okay. So that ain't gonna work either. I don't know if there's an easier way to do this. I might just have to give up and have that obnoxious looking square. Oh well. All right. Can I copy all this? All right, it didn't copy all the constraints though. Actually, we should probably go through and delete most of these. Because it did some weird, like, has to be parallel kind of constraints. All right, there we go. This stuff can be really hard to read. Alright, trying to get rid of any unnecessary ones. Nine degrees of freedom. Okay, how did I get this part worked out? So that can't go anywhere, but this can't. Oh, it's gotta use a dimension. And okay. So that probably locks most stuff in. Yep, everything except a... Everything except those angles, and then we need to get these, get the rectangle as well. That should be 0.125. There we go. And now 0.75. All right, that locks in the rectangle portion thing. All right, getting closer. What are we missing? Probably just the angle on these arcs. Yep, okay. It can change that. So how did we do that over here? .125. We did a single arc. I'm still confused. Oh, thank goodness. I thought I forgot to click record for a second, but I did. Okay. Let's see. So I did something over here to lock all this in, because this can't move. Like, there's nothing I can do here. Promise I don't remember what. I did distance between those. Oh, I specified this one. Yep. Okay, so that has to happen over here. Gonna make some dimensions cross, but I guess. So from this point to here is 1 inch. There we go. And then our pad, 0.125 reversed, okay. Should be, yeah, it looks good. All right, so now we have the wall mounts to hang it. So the nail head can slide in there. Nice. All right, next step. I need to go in and hollow this out. This went in 1/4 inch. So you know what? This one. I'm gonna go in 3/16 instead of 1/4 inch. That way when I hollow it out, I don't have an opening there. What's 3/16? 0.1875. 0.1875. Okay. All right. Hide that and show that. So now it should be a lot thinner in there. Yep, it is. Okay. So that basically leaves a 1/16 inside, which should be enough for any nail, I would think. I guess I'll find out. All right. Let's get this lined up. Oh, how tall is this thing again? I don't even remember. Yep, that's the one. 2 inches. So I want to go up probably, by default, probably want to go up 1 3/4. So I'm thinking leaving a 1/4 inch thickness on everything. All right, so we'll go here. Okay, let's line this up. Start a sketch. All right, rectangle. I don't even remember how big this thing is. Hold on. 1 3/4. We did 1 3/4 thick. Let's just take a screenshot of this. This way I just have a reference. All right. Close that. Go back to this one. So we know it's 1 3/4 thick, so I need to do 1 1/4 on this. 1.25. And then distance from here to here is 0.25. And the distance from here, well, that's not necessary. On this one, how big was it? Oh, I didn't even capture that dimension in my screenshot. 5.5. So we need to do just 5. Okay, so this will be 5 inches. And then distance from here to here is going to be 2.5, I guess. There we go. And then, all right, so that's done. And then we need to use that to make a pocket. And it needs to be 1.75. Okay. Nice. So that lines up pretty good. Yeah, I just had a thought. Originally, I was going to make like a shelf inside it to put the circuit board with neopixels on, and then like have the teensy and everything hanging down. But I'm thinking I can design just a whole different part. Like the base can just fit inside the thing. I think that would definitely work. Just thinking through that right now. Yeah, I could design like a base that like holds the circuit board up in high enough kind of thing. And then I could do something to like actually mount it to that base, mount the circuit board to the base. This is what happens when I start off my easy projects and they just get more and more complicated. Okay. I think that makes sense. In the meantime, though, this part looks really good. It still needs to have the edges rounded. But we're getting there. Cool. I think I've just realized too that in the process of doing this, I'm making a like a really good like standard base for just dropping in a bunch of cool acrylic signs, like something that's easy to switch out. So maybe that's a thing I could do. Want to support the channel, buy custom acrylics. Well, nicely done. All right. So I think for the next portion, I designed the base. Yeah. Design the base. And design it such that it's just for doing the points to screw it back in. So for the screws on the corners. At least that's what I'm thinking of doing. I should drop this part into like a into a quote thing and just see like how much it would cost to make. I might do that real quick. Just for a fun little experiment. Let's see, export. I'm gonna do a step. Oh, that probably exported the whole thing, like the whole assembly, which is not what you want. Although maybe because it wasn't selected, it didn't. Let's find out. Let's open the one I just exported and see what's in it. Just the base. Okay, that works. So yes. So now let me... So there's a company called Shapeways, which does this kind of 3D printing stuff. I don't know if I have to log in or not, though. I might have to. All right, give me 2 seconds. Let me, so I don't accidentally show something, I'm going to put this on me just for a second while I log into this. No records. Let's see. Looks like I may not have an account, actually. All right, we're making an account just for this. All right, let's upload a quick file. I just want to know right now, like, if this thing is going to cost me, like, you know, $200 or something. Interesting. So it's $150. Wow. That's like really expensive. Hold on. Let me see if I can pull this up and show it. All right, so I think I broke the website. You can upload up to 20 models at a time. Hang on, internet's running slow. Hopefully it's not like crashing my stream. Okay, I definitely broke something. Let's try again. Totally reload the page. I apologize for dragging this out. I just want you all to see this because the prices are insane for just being a little part. I guess it's not that small, but still, it's like intense how much it cost. Okay, here we go. Let me make sure there's no secret things. All right. So look at this. Like, not too complicated of a shape or anything like that. And it's wanting, like, minimum cost is like $150 for the first available plastic, right? And then if you pick something specific a little more, we can print it out of aluminum for $2,200. Jeez. Ah, platinum's not available. That's like a really intense price, though. I didn't think it'd be. I've gotten bigger stuff from them before that wasn't that expensive. So that's impressive. Right. So what to do? What to do? I think I phone a friend, find somebody who has a 3D printer. How's it going, Beth? Hope you're having a good Thursday. But yeah, I think I find a friend with a 3D printer. I really need to get one. Problem is getting a good one is expensive. All right. Well, that's a thing. I refuse to quit though. It might honestly be well, it wouldn't be. It'd be impossible to build. It's your Friday. Oh, good. You have a day off tomorrow. Monday's Labor Day too. I'm excited for a 3-day weekend. I cannot believe that is that expensive. Like, wow. All right. So I guess next steps are to do the base. So for the base, Shapeways is a very like professional company when it comes to 3D printing. I wonder if I can get stuff 3D printed other places for like cheaper. Problem is I'm hesitant to like try anything that's not professional because I know it won't turn out as well. All right. We're doing the base, which means a new part. And it needs to start off in these dimensions. So I'm just trying to think this through. Yeah, I think I have to get the dimensions, or I know the dimensions on this for my screenshot. So 5.5 by 1 3/4. So I just got to make a shape like that. So we need a new part. I wish I could reorder these things. All right, let's rename this the cover. And then within this, we're going to make a new body. Let's turn the base off. Whoops. There we go. And we want this on the, probably the ZX actually. All right, which way is this going? So positive Y is away from us. Okay, I think that's exactly what we want. I matched the background. Oh no. I'd like to offer a formal apologies to my viewers for wearing the same color shirt as the background. Oh, that's really funny, actually. Yeah, it would be cool printed out. The problem is it's so expensive to get someone else like to pay for it to have it 3D printed. If I had my own, I could do it myself. But oh man, I can't believe I didn't even think about that. Wearing the red shirt today with the red background. I'm working on getting a different background, right? Something that's like not so red. Um, but that's this weekend's project. So hopefully Tuesday I'll have something different. That's really disappointing. You can get 3D printers really cheap. But the problem is like they only make really small stuff or they're not very good. It's something good is gonna like really good is gonna still cost over $1,000. No, I bet you could get a pretty decent one for like 500. I know I am being a floating head right now. That's really funny though. Like totally didn't plan that, but it just sort of happened that way. Oh, excuse me. What's half of 1.75? Is that 0.875? Yeah, 0.875. There we go. So that's done. Just make this easier to read. I'm going to have to go back and clip that moment where I learned that I was the same color as the background. You think I would have noticed? I forget how obnoxious the color can be. Okay. I really wish I could like hide the chair because then I actually would be like a floating head here. All right, so that sketch is done. Then we need to pad it. I'm thinking a 1/4 inch, just like everything else. It's gonna be very like robust thing. All right, now we need to figure out where exactly it's going. Where's the base? Well, not there, that's for sure. Oh, I moved the origin around a bunch. All right, so it needs to come down in the negative come down on the Y by 2 inches, and then go up on the Z by 0.875. Oops. There we go. Okay, now that's an excellent little cover. I wish there was a way to like, I should import like a model of a quarter or something, right? In here so that I can have like a reference for how big something is going to be. All right, cool. Turn the screws on again so we can see those, and then the acrylic sign. Okay. So I want to use the same screws. Here. All right, so if I use the same screws, I need a little bit of space in here. So I don't know how far from the edge I should put them. How wide is the head? The head is 0.219 inches, so probably like a 1/4 inch. So probably do a 1/4 inch from each edge would be a good spot for it. And then how thick is the head? 0.08. Okay, that's fine. So on this piece here, we're going to do another sketch. And then we're going to do several circles. So 0.25. If I bring them in too far, this is going to make this kind of hard. But we'll see. Oh, I keep forgetting that's a radius. This should be 0.125 because it's a radius. I'm like, man, the screws are huge. All right, and then I need to duplicate this. Copy. There we go. And get rid of that parallel constraint. Let me just make a bunch of circles. Be easier. All right, 0.125. So these will be the screw mounting points. So we're going to have to do a little indentation. This big indentation will be for the heads, and then a small hole that goes way up in. And then we might have to expand the edges of the cut on the inside to allow for that. Might have to change that sketch, actually. That'd probably be the best way to do it. Okay. So I need to place these. And I wanted them to be a 1/4 inch away from the edges. So we know that this is 5.5 all the way there. So it's going to be 5 1/4. No, 2 1/4. 2.75. That's what it should have been. I'm butchering this. So 2.5? Yep, that's right. Ugh. You can tell it's getting late. I'm starting to get tired. Also, for anyone who's interested, this is totally random, but something that I'm going to check out after the stream. There's going to be a new rocket launch. Firefly Aerospace is launching, I think it's their Alpha rocket, the Firefly Alpha. It's going to be the first time it's going to be their first attempt. So I think that will be really cool. And if you get a chance, you should definitely check it out. Okay, I have no idea what this one should be. I know that that's 3/4, 1 3/4. So hold on. So 0.875 minus 0.25 equals 0.625. Yep, there we go. I feel like we could take bets right now on whether or not they're going to scrub the launch or not. Because first time you launch a rocket, it's really hard to get everything to go right. And oftentimes, the way the systems are now, they shut themselves down. So, and I suspect there's a very good chance that that happens, that it, detects a problem and then shuts itself down before it does anything catastrophic. If it does launch, I don't know that there's ever been a company that has successfully gotten a liquid-fueled rocket to orbit on the first try, which is what they're going to try and do. So if they do succeed at that, they might be the first ones, which would also be extremely cool. So there's a very low chance that this succeeds all the way, but nonetheless, it will be entertaining to watch. Just hope that they can go for an on-time launch and not have it scrub. All right, there we go. The whole thing locked in. All right, close that. And then we are going to do a cutaway. And this is going to be a 1/4 inch. 1/4 inch is too much. This is going to be an 1/8 inch. I know, me too. Launches are cool. Like I said, though, it's going to be nerve-wracking for them because it is the first time that it's their first attempt with a brand new rocket. Okay, what's next? I guess the holes for the actual screws. What did we make those up here? I need to find the sketch. Let me turn off the acrylic and the screws. That's that one. There they are. 56 thousandths. Where'd that number come from? 0.112. That's where it came from. Oh, that's exciting. I always want to see one in person. I've not had that. I've not been fortunate enough to see a rocket launch in person yet. All right, so we need to turn that off. And then go back down here. Oops. And do a sketch. This constraint does not make sense for... Got it. 56 thousandths. All right, and then I get to go through and do all of these again. Okay. Oh, and then we gotta do the side ones. Whew, I'm getting tired. I want to push on a little longer, but I don't know how much longer I'm gonna make it. All right, those are the holes for the screws. And then they need to go, we need to do a cutaway with that. And I guess it just needs to go all the way through, so 1/4 inch. Okay. So that looks good. Now, you'll notice that the cover here, when I turn it on, how that, oh, what's the word? How that hole is kind of on the edge of the wall there. So this wall doesn't come out far enough. So basically we need to add a little piece on each corner to help, to give it enough room to stabilize. So I think we just need to, probably the best way to do this would just be to amend this sketch. Yep, this one right here. Whoa. Like I said, I'm wearing down a little bit. All right, so how do we change this one? Also, I'm making these walls super thick and everything because it's 3D printed. If it was like, obviously like plastic can be much thinner than that and still be really strong. And you typically do that if you're just doing like injection molding or something, like traditional ways of forming plastic. You have a form, you fill it up with molten plastic, you let it cool, and you break the form open, and there you go, you have a part. And if that were the case, if we were definitely making it that way, I could make it a lot like thinner and still count on it being strong enough. It's also a much more accurate method. 3D printing stuff warps a little more. But you can print shapes with 3D printing that you couldn't with injection molding. All right. I think I need to delete this whole thing. We'll see how far through this I get. But I need a line. Need a line, a line, and a line. All right, move those out of the way. And then arcs. Like that. Then one here, like that. One here, like that. And then one here, like that. Oh no. Go back. I didn't want it to connect there. Like that. Okay. And then I need to connect up a bunch of stuff. Let's try that again. There we go. And so this is going to slowly pull everything into the shape, and you'll get kind of the idea of what I'm going after here. Then hopefully I'll find a way partway through this to make this like much easier to do, or easy to constrain. It's going to be weird to figure out the measurements to constrain the arcs, so. But first things first. We're going to do all the other stuff. All right. Then tangential constraints on everything. We'll see what kind of ridiculous shape this forces it to be. There we go. There. And 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 there. All right. Well, that's a good start. I guess we could do some radius constraints. These are going to be 0.125. Because I'm going to make them 1/4 inch diameter. All right. This needs to go up here. This is coming in. This needs to come down here. This needs to come way in. Nope, don't break. Nobody freak out. All right, this comes down. It's a little better. All right. Distance from here to here, 0.25. This is hilarious. This little tiny curve. Oh, man. All right. And then probably 1.25 to that. Yeah. No. 1.5. All right, and then for the side ones, so they usually go, so it needs to be 2.5 from the center. Oh wow, what has happened here? That's a disaster. It's crossed. Let's bring that in. Nope. This one. Bring it inside. Come on. You can do it. There we go. Better. I think. I probably need to constrain those radiuses to certain points. That would be the next step. Because there's a lot of craziness going on right here. Oh man, if I can even find the correct ones to constrain. Oh, there's a gnat in here. There we go. Better. All right, so these ones need to be constrained to the spot where the screws are. All right, let's close this for now. Go down here to this one. Two 2.5, 2.5, and 0.625. Okay. Nope. Hopefully lets me do this. There we go. Somewhere in here is the right way to do this. Okay, starting to take shape. All right, and then each one was 0.625 from the center. So that's 1.25 apart. So a 1/4 inch from the bottom. Oh man, that made everything go wrong. This is going to be a really hard shape. All right, this is going to be 1.5. Can I fix this? It looks like it. There we go. All right, that makes it look more natural, I guess. All right, 0.25 and 1.5. All right, tons of lots of constraints. So we'll do our best with all this, but it is going to be a bit of a mess. All right, so now how to constrain these. First of all, these have to come way in. So I figured out a way to do this on the other one, like do some constraints to make sure it lined up like just perfect, right? I'm not really sure how to do that here, or if that's even necessary. I should probably just set the radius of them all, and that would do it. Yeah, just radius them all to 0.25. That would probably set it. So 0.125, sorry. $125 thousands. What world is that the one I... There we go. Oh, it did it again. Oh, because it's already at thousands. Dang it. That makes more sense now. Fully constrained sketch, except this one's wrong. There we go. All right, so that was a lot of work just to get a little wave in there, but it should make it look a lot better. Yeah, so it's not like looks really weird or anything. And I kind of wanted to learn how to do that. All right, so now I add the cover, and we should see that those holes, yep, where they are is fine. So now I need to drill holes in here the same size as those. All right, so I need to look at this one again. I think after this I'm going to be done, but let me take a screenshot of this one. Because I basically need to copy it. Oh, not that part, actually. Turn the cover off. Thank you. Here we go. Cancel. Geometries are not part of the active body. My bad. Why is it not active? There we go. Turn that off. There we go. It's like, come on, I'm so close. All right. That's too big. That's too big. That's too big. And that's too big. All right. Radius constraints 0.056. 0.056. 0.056. 0.056. Okay. And then distances. From here to here, it's 0.25. From here to here, it's 1.5. No, I think both of those were wrong. Well, that first one was right. It was 1 3/4. Oh, that is right. I think it's just positioned wrong. Weird. Not wrong. I'm about ready to end the stream, but I'm in that like zone right now where I'm getting it done, so I want to just finish this piece up. All right, then 2.5 from the center. All right, that's all constrained. And then we need to cut in, I think, how long are these screws? I think they're 3/4 inch. Yep, so 3/4 inch minus 1/8. So 0.625, yeah, that should be the ideal. Honestly, we should just go 3/4 inch, just give it a little extra room. Just in case. So let's just do that. Cut 0.75. Okay. That shouldn't go through because it's plenty, yeah, plenty tall. All right, and then I turn this cover on. And we see that, yep, it's lined up. Sweet. So now we got the fully mountable cover. And then inside we have to do the parts that are going to hold up the circuit board and everything. So we'll start working on that next time, as well as figuring out like how we want to do the circuit board. But yeah, I think we got pretty far there. Sweet. Well, thank you all for joining me tonight. This has been fun. And hopefully everything went fairly smoothly. And I will see you all on Tuesday. Have a good night.